Today's topic is stoichiometry. You're going to need your notebook, periodic table, and a calculator. So let's begin. So what is stoichiometry? It's examining the relationships between amounts of substances going into a reaction and coming out of a chemical reaction. And in these types of problems, you're going to be given an amount for one substance in the reaction, and you're going to be asked to determine an amount of a different substance in the reaction. So in order to do these problems, we're going to use mole ratios, and we're also going to utilize the numbers from our conversion factors that we did with moles. 6.02 times 10 to the 23rd representative particles, either atoms or molecules, 22.4 liters, and the molar mass of an element or a compound. Stoichiometry problems can be solved using dimensional analysis or using proportions. And in this lesson, I'm going to show you how to solve stoichiometry using the proportion method. And the first step to that is you write the information from the question above the balanced reaction in the appropriate place. So let's see how that would work. So as we read the question, we're going to take information in the question and put it over the balanced equation. So it starts off by saying how many moles of chlorine. So that's what we're looking for. That's going to be X. So over the Cl2, the chlorine, I'm going to write X moles. I put X with the unit of what I need to solve for. And then as I keep reading, it says are needed to react with 5.0 moles of sodium. So over the sodium, not the sodium chloride, but just the plain sodium, I'm going to write 5.0 moles. So that's step one completed. The next step is we're going to drop the units below the equation, making sure we keep them consistent. Whatever unit we have above the reaction, we're going to use that same unit underneath the reaction. And we're going to write the information from the balanced reaction under the reaction. So the first thing we do is we drop the unit over the Na on the reactant side. We have moles, so we're going to drop that unit underneath the Na, keeping it moles. And over the chlorine, again, there's moles. We're going to drop the unit underneath. Now, to figure out the number of moles from the balanced equation, we need to look at its coefficient. Remember, the coefficient is the number of moles. So we're going to take that information, the number of moles from the balanced equation, and we're going to write that under the sodium. And then we're going to look at the chlorine. Well, remember, the coefficient is the number of moles. In this case, there's no coefficient written, which means it's understood to be 1, and that would be equal to 1 mole. So we dropped our units, and we took the information from the reaction and put it underneath the reaction. Step 4 is to set up a proportion, and then we're going to cross multiply to solve. Going back to our reaction, the proportion is kind of set up for us already. We have numbers above the items in the reaction, and we have numbers below. Those are going to become our numerators and our denominators in our proportion. We're going to take 5.0 moles above the Na, and we had 2 under the Na. We're going to set that equal to the information for the chlorine. Well, with chlorine, we have X moles above the chlorine, and we have 1 mole below the chlorine. So there's our proportion. The numerators came from the question. The denominators came from the balanced equation, and now we're ready to cross multiply and solve. 2 times X is going to equal 5 times 1. We need to divide both sides by 2. And the answer comes out to be 2.5 moles of chlorine. Let's try another practice problem. This one says, how many moles of sodium chloride? So over the sodium chloride, which is on the product side, we're going to write X moles. And as we keep reading, it says, will be produced if you react 2.6 moles of chlorine gas. So over the chlorine, which will be on our reactant side, we're going to write 2.6 moles. And then as we continue to read, it says with an excess or more than you need of the sodium metal, which just is telling us that there's plenty of sodium, and we're going to use up all 2.6 moles of the chlorine before the reaction ends. All right. So that was step 1. Take the information from the question and write it over the balanced reaction. Step 2 is to drop your units. So since we have moles above the chlorine, we're going to put moles below. And since we have moles above the sodium chloride, we're going to put moles below that as well. Now remember, the moles come from the coefficient in the balanced reaction. So looking at the chlorine, there is no coefficient written, so it's understood to be 1. So I'm going to put 1 mole underneath the chlorine coming from the balanced equation. And looking at the sodium chloride, its coefficient is 2. The coefficient means there's 2 moles, so I'm going to write 2 moles underneath the sodium chloride. Step 4 was to set up our proportion. Remember, we're going to take the numbers above the reaction, make those the numerators, put the numbers below the reaction as the denominators, and set them equal to each other to solve. So we should have 2.6 moles over 1 mole is equal to x moles over 2 moles. And our last step is to cross multiply and divide. So we have 1x should be equal to 2.6 times 2. It comes out to be 5.2 moles of NaCl. Let's try example 3. It says calculate how many grams. Well, in this case, we're asked to find the mass in grams. We're going to solve it using those same steps that we did for the mole-mole problem, only in this case, the units are going to be grams and not moles. So over the ammonia, we're going to write x grams. And even if you don't know the formula for ammonia, by reading the question, we can see that it's asking about the grams of ammonia being produced. So it has to be on the product side. And there's only one thing on the product side. So over the NH3, we're going to write x grams. And as we keep reading, it says when you react 2.0 grams of nitrogen, so over the N2 on the reactant side, we're going to write 2.00 grams. And if we keep reading, it says with an excess of hydrogen, which is just letting us know that there is plenty of hydrogen, and we're going to use up the entire 2.00 grams of nitrogen in this reaction before it stops. So the first step was to write the information from the question above the balanced reaction, which we just did. The second step is to drop our units. So since there's grams above the nitrogen, we're going to put grams below. And since there's grams above the ammonia, we're going to put grams below the ammonia as well. The next step was to take the information from the balanced equation and put that underneath the equation. So when we look at the N2, there is no coefficient, so it's understood to be 1. We always want to bring the coefficient down. But in this case, we need to know the number of grams. So we can't just bring the 1 down. We also need to find the molar mass of N2. And if you remember, we look on the periodic table. Since there are 2 nitrogen in that molecule, we're going to multiply its atomic mass by 2, and it would be 28.02 grams per mole. So that 28.02 is going to go in the denominator, because we can see that the equation is telling us there's 1 mole of N2, and we know that 1 mole would be 28.02 times 1. Going over to the ammonia side, again, we're going to bring that coefficient down. We always want to bring the coefficient into the denominator, telling us the number of moles, but we can't stop there because grams is the unit in the denominator, so we need to find the mass of NH3. So looking on the periodic table, we know nitrogen has a mass of 14.01. There are 3 hydrogens, so we're going to multiply 1.01 by 3, and then we're going to add those together to get a total of 17.04 grams per mole. So according to the balanced equation, we have 2 moles of ammonia. We just determined that each mole would have a mass of 17.04. So to find the mass of 2 moles, we're going to multiply by that coefficient. So now we're going to take our numbers, the numerators over the denominators, and set them equal to each other. So we have 2.00 over 28.02 set equal to x over 2 times 17.04. We're going to need to cross multiply. So we have 28.02x is equal to 2.00 times 2 times 17.04. If I continue with the math, 28.02 is going to equal 68.16. We need to divide both sides by 28.02. And we get a rather long remainder. We need to go back and look at the original question. We were given 2.00 grams, which has 3 sig figs. So we need to round our answer to 3 significant figures and put the units grams of ammonia after it. You're going to try example 4 on your own. Remember to follow the steps in order. You can use the last example as a guide if you get stuck. Pause the video while you work, and when you have an answer, start the video again. So let's see how you did. The question says how many grams of calcium nitride are produced. So even if we don't remember how to write formulas, and we don't know what calcium nitride would look like as a formula, we know what's on the product side. And we should hopefully remember that calcium nitride would be calcium and nitrogen bonded together in a compound. We're also given 2.00 grams of calcium reacting. So on the reactant side, that's where the calcium is by itself. And it says it reacts with an excess of nitrogen, which means there's plenty of nitrogen and we can ignore the nitrogen in this problem. All right, the next step is we drop our units. Since there's grams above the calcium, we put grams below. And since there's grams above the calcium nitride, we put grams below that as well. We're going to take the coefficient and drop the coefficient down. That tells us the number of moles, but we're not just interested in the number of moles. We need to know the mass of 3 moles of calcium. So we're going to need to look on the periodic table, and calcium's atomic mass is 40.08. So we're going to write that mass in the denominator. So our denominator now is 3 times 40.08, which would be the mass of 3 moles of calcium. On the other side, we are going to take the coefficient and bring it down. Well, there is no coefficient written, so it's understood to be 1. But we're not just interested in the moles here. We need to know the mass of 1 mole of calcium nitride. So we can see that there are 3 calcium, so we're going to multiply calcium's mass by 3. And there are 2 nitrogen, so we're going to multiply nitrogen's mass by 2. And then we're going to add those together to get the molar mass of calcium nitride. And it's 148.26 that we're also going to put in the denominator. So remember, the information from the question went above the equation. The information from the balanced equation goes below. And now we're ready to set up our proportion. We have 2.00 over 3 times 40.08, and we're going to set that equal to x over 148.26. We're going to cross multiply to solve. So we have 3 times 40.08 times x is going to be equal to 2.00 times 148.26. I'm going to get rid of my parentheses there by multiplying through, and I can see that I'm going to need to divide 296.52 by 120.24. And again, I'm going to get a bit of a remainder. I have 3 significant figures in the number that was given to me, the 2.00 in the question. So I need to round my answer to 3 sig figs. So it should be 2.47 grams of calcium nitride. Now let's try practice problem 5 on your own as well. Remember to follow the steps in order. You can use the previous examples as a guide if you get stuck. Pause the video while you're working, and when you have an answer, start the video up again. So let's see how you did. How many grams of CH4? So over the CH4 in the balanced equation, we write x grams. Is needed to produce 50.0 grams of CHCl3. So over the CHCl3, we write 50.0 grams. Remember, our next step is we drop our units. We have grams above the CH4, so grams go below, and we have grams above the CHCl3, So again, grams go below. Let's go back now to the CH4. There's no number written in front of it, so the coefficient is understood to be a 1, which means there's 1 mole. But we're not looking for moles, we're looking for mass in grams, because we're going to calculate the molar mass of CH4 by looking up the elements on the periodic table. Carbon's mass is 12.01. There are 4 hydrogen, so we're going to multiply hydrogen's mass by 4, which gives us 4.04, and then we're going to total that up, and that comes out to be 16.05 grams per mole. And that's going to go underneath this CH4 in the balanced equation. Now let's go over to the CHCl3. Its coefficient is understood to be 1 because there's nothing written, so we're going to bring the 1 down, and we're going to need to find the molar mass of CHCl3. So carbon has a mass of 12.01, hydrogen has a mass of 1.01, and there are 3 chlorines, so we're going to multiply chlorine's mass by 3, and then we're going to find the total. And that comes out to be 119.37 grams per mole. So that number is the mass, and it's going to go underneath the CHCl3 in the balanced equation. So now we have our numbers for our proportion. We have x over 16.05 is equal to 50 over 50.0 over 119.37. So now we're ready to cross multiply. We'll have 119.37x equal to 16.05 times 50.0. 119.37x equals 802.5. We're going to divide by 119.37, and that answer comes out to be 6.72279. 50.0, the original number from the question, only has 3 sig figs, so we're going to round our answer to 6.72 grams of CH4. So how did you do? Hopefully you got that right and you can celebrate. If you didn't get it right, make sure you check your work to see where your errors might have been so you don't make those same mistakes again. Thank you so much for joining me today in this introduction to stoichiometry, and I hope to see you soon.